Alright folks, here's a quick tutorial on doing the electron configuration, orbital notation, and shorthand notation for our quiz tomorrow. Now the electron configuration, that's just where we use our numbers and letters and exponents to figure out or to show how the electrons are arranged in particular elements. So from the sheet, one of the sheets that we got in class today, if you take a look at number 2 on the first section, Rhenium. Rhenium, you look at the periodic table, RH has an atomic number of 45, and therefore it has 45 electrons. Now to figure out how those electrons are arranged in there, this is our guide. This is the Aufbau chart. You'll get this on your test or quiz. And we start here, and we follow the arrow, just like chutes and ladders. So we follow this arrow down, putting electrons in our sublevels as we come across them. So the first place we put them is in the 1s sublevel, and we can fit 2 electrons in there. We have 2 of our 45 accounted for. So here we've hit the 1s. Where do we go to next? We'll follow this arrow. We go to 2s. And we can fit 2 electrons in an s sublevel there. And that gives us to 2s2. Continuing down, we get to 2p. And we can fit 6 electrons in a p sublevel. We follow that down to 3s. We can fit 2 electrons in there, follow this back down to 3p. We can fit 6 in there, and then 4s. We can fit 2 in there, and then now we're at 4s, we go to 3d. We can fit 10 in our d sublevel, follow down to 4p. I'm just going to carry this over down here. We can fit 6 in that, so now we're up to 36. We just have 9 more to go. After 4p, we go to 5s. We can fit 2 in there. After 5s, we go to 4d. And that's going to get us to, let's see, we've got 30, 38. We need 45. So 38 to 45, that's what? 7. So we're going to have 7 electrons in our 4d sublevel. Now to do our orbital notation. This is where we use our boxes or lines with our arrows in it representing the electrons. Oxygen has 8 electrons. We're going to stop in our first box there, a 1s orbital. Looks like this, and we're going to put an arrow up and down showing the 2 electrons in our 1s orbital. Then we follow up and we end up with a 2s sublevel. And a 2s sublevel has also 1 orbital. That should say 2 there. Again, we can fit 2 electrons in there. After we get to 2s, we end up with 2p, and a p orbital, or a p sublevel, is composed of 3 orbitals. And we have 4 of our 8 there. That means we can have 4 more electrons here. We put 1 in each, and then if we have any more, we're going to double them up. So we'd have 2 electrons in our 1s, 2 electrons in our 2s, and 4 electrons in our 2p. Now the other way to do this is with shorthand notation, and for this we need to use our noble gases. So we look for the next smallest noble gas from rubidium, and we look at the periodic table. We go up 1 row and all the way to the right hand side to find our noble gas, and it turns out we're going to end up with krypton. Krypton's electron configuration ends with, it is in the 4th row down, so if we look to here, we're going to be narrowing ourselves down to here, and it's at the end of our p block. So that means krypton includes all of the electron configuration up through 4p. So krypton has 36 electrons, and rubidium has 37 electrons. So we just need 1 more electron in it and we'll be filled up. So where do we go after 4p? Well, we follow that arrow down to 5s. And since we only need 1 more electron, we'll just call it 5s1. If it was something bigger than rubidium, if we were over there a little bit further down to maybe technetium, Tc, we would continue down this road until we got to enough electrons to equal the number of electrons in the element that we're looking for. So that's how you do these electron configurations.